Hi, and welcome to this episode 1, Designing the Lithium Speaker in Autodesk Fusion. So, first episode, and this is what we're going to talk about. How to build a completely circular design with additive manufacturing, Wataya Digital Product Passport, and of course everything what we do is also in mind for how to repair this one, how to rebuild it, repair it, and one day maybe even recycle it. So this will be the first episode. The focus today is to go through Autodesk Fusion, and I will show you a little bit how we are designing for additive manufacturing. So we are in Autodesk Fusion. This is the complete assembly you're looking at of the speaker Lithium 2. Lithium 2 is when it has a carbon fiber driver. It's a hi-fi, high-quality speaker. At the moment, it's a passive element. It can be equipped in the future with inside electronics more than a passive crossover. But at the moment, it's mainly aimed for either smaller kind of shelf speakers or as a part of a Dolby Atmos music setup. So so what if this high-end sound could start with recycled material and also using 3D printers and sound amazingly good? That was the whole kind of vision we had for Infinite. And that's what I'm gonna show in this series. But let's first have a look at the inside of the speaker. So one thing what was super important was to have a consistency in where the digital product passport was aimed and where it was placed. And obviously you want to place it in a place where the user and the consumers can easily find it and get access. So in this cut you see that it's placed inside the actual dome, on the top dome, the top atom, and it's always beneath the actual logo. So it's always beneath the logo system. But of course, there's no way you can get to this without tapping it with your phone, and that's the whole intention, that you shouldn't be able to peel off an identifier, a data carrier, so easy. It should be part of the whole life cycle and the whole eternal life of the product, so to speak. So let's go in a little bit deeper, and I wanted to show you also how we initially designed Lithium and how this kind of atomic style came about. So let's jump into the assembly. We are now in the beginning of the design. So in Autodesk Fusion, your whole design history is saved, and that's a pretty amazing thing. You can always go back in your history and see what you have done. So the whole concept for Infinite Acoustics was to build the world's most circular hi-fi speaker, one that can be made locally in microfactories in 3D print farms with recycled materials, using of course hybrid materials like Adnite, which is basically built for acoustics because it also contains EPDM rubber. We will talk about that later on in the series, how we developed the material. So when we started the design, we knew that we had an acoustically very, very good material. We wanted to build something which could be branded in a cool way, but at the same time thinking about how music and waves are round, they are not cubical, which most speakers look pretty awful as they are based on MDF boards or different type of wood structures where you have that element that you have to follow. So this was the round kind of atomic design that was its basic style and form and shape, and that was done with an organic form shape tool in Fusion, which is very, very nice, where you can organically shape whatever you want to have. So we fell for this shape. What was also important, as we knew the limitations of the 3D printers. So most 3D printers, depending on which type, in this case we wanted to use FDM, Fused Deposit Modeling printers, which is the most common 3D printers. We need one flat surface. We don't want to build something which have an incredible amount of support and assistance to build. So we needed to have something where we could basically build a home for a driver, for a tweeter, or for a woofer, where it will be very complacent and fit very well, and it has to be able to print well. These prints, you can imagine, are on a subwoofer, not Lithium. It's up to 100-hour prints. So you also have to look at the machines, have to be able to do these without basically failing all the time. So there is some openings here, all the holes. These are actually connection points, because a speaker most of the time is not one element, it's minimum 2 elements. Very often we see in the line arrays we build, you up to 5 or 6 elements. So the thinking was basically to build the atomic speaker from the periodic table and enable you to build different designs depending on futuristic materials, or materials as such. So we make a hole for, in this case we have to have an output for the pins to connect the speaker. So that's something what is cut out. So this is basically how you build it up. You start from a shape, and then you start to add things, and you can even add component as you go along. So you see we do have the connectors here already placed to see how that will work. And then of course all the different analysis with the speakers and the drivers is done as you work your way through the design. And maybe now you saw also some magic happen. We can go in and have a look in the section. So we actually put in kind of a sound diffuser inside the material, very similar to what you see behind me. And that's of course to break the sound waves and disturb them in a way where they actually don't give any additional sound from the box or from the casing itself. So there we use the Autodesk Fusion's design tools, which are very, very efficient to do that. So you can basically build a small geometry, and then you can automatically place that over a bigger surface. So this is how we go along. And of course we have all the cutout radios, the holes and everything for the speakers. These are done as separate components. And everything is done in a way where we work our way through. And let's do an analysis again. And let's take this one. So here you see also how we use the electronic part of Fusion. So everything is designed in one design process. Of course it's parallel processes, but this is also a way where you basically build your prototype, you manufacture it, you build a crossover prototype, you take it to the lab, to the sound lab, you do all your measurements, you do all your testing, and then you go back into Fusion and redesign. So this is the crossover. It's also built, the whole PCB and the design, the schematics, the whole thing is done in Fusion. So this is manufactured directly from a Gerber file. All the coils and polycaps are done, are made by hand from our supplier. And of course all the setting, how this one goes in, you see we can build in. So let's continue the setup here. So we basically use the circuit board to do also the kind of the placement in here. So let's just switch it off. You see, so it actually made the cutout in the design. So that's of course because it needs to be very simple to mount this in the factory. and also to remount and disassemble and use some other options or upgrades. If we want to go full Bluetooth and have the amp inside, it's also capable. We just need to follow these different structures that are built up. So yeah, so I'm continuing to go through the design. Let's switch off the analytics again, and you see now we place the bolts, we place the carbon fiber driver, and of course it's very easy now to also judge and see, you know, where do we have the drivers, where do we have everything. We also put numbering in, so this is the product ID actually is three-dimensional, and it's put inside just to make it sure that we know which version we have and these kind of things. So of course you can trust the digital product passport, but we also do this kind of physical numbering inside just to be absolutely sure. So this is the cutout. Now we can also calculate the volume for the driver and see how far in the magnet is reaching. So everything we do now in design is made both to enable us to manufacture this in a proper way on 3D printers, but it's also made so we can quite easy disassemble and repair this speaker. It's not done in a way where you lock things in, but you can actually allow for modifications and things like that. So both all the drivers and the crossovers can be fitted into other cabinets, and also the cabinet can be modified in a way where there is different drivers that fit, that have a standard size, and you can also modify the crossover and things like that. There will also be other kind of stands and these kind of opportunities, which comes along when you do the design, when you continue, and at the end you see that yeah, everything is where you want it in this design. So you see, another thing we had to do is, because these are printed, each of the casings are printed individually, and when they are mounted together, we're using a special glue to get the mounts together to build the full speaker. And this was a invention we did during the montage, that these small gutters are actually collecting any kind of additional glue that would actually come out to the surface. So this is taken up by these little gutters, and the pinholes here is to exactly find a perfect alignment between the different atoms. So this is basically how this is built up. This is the structure, how you build it up. And you see these dowel pinholes, they go through here in the cut section. And yeah, we are extremely happy with the result. These speakers sound absolutely amazing. So it's a two-way passive speaker, and it have the What.io digital product passport up here in the cut section, always added. And also all these different parts are available. You can buy the chassis separately. You can also get the CAD files, the STL files. So you have the ability to build them yourself, modify them yourself, and tag along. So you see this atom is a little bit different. It's a 1286. And there's also one more place for a PCB in the upper side. These are cable attachments, and these were also put in just to simplify, to get all the cables inside to align nicely, so you don't have a total chaos there with cabling. So these were added afterwards when we got some reviews from the montage. So that's more or less how I will show how this works. And you see this full assembly is also very important to understand, that just like you do in any other kind of bill of materials solution, all these things are included into Fusion. So all the small bolts and custom details and different parts and wall mount, everything which is here, the crossovers and so on and so forth, even NFC tag, everything is built into the assembly. And because it's built into the assembly, this is also something which is super easy to extract and work with What.io in the next step to build up the whole structure in the digital product passport to enable you to order the spare parts and get all these things out of the box. So yeah, that's basically where I wanted to end this. So this one is designed, every single part is designed to be made in microfactories. All these tolerances are tuned for FDM printers, and it's all done with Adnite, this material which is customly done for acoustics. So yeah, this is just the beginning of this lithium story. Next up, we will show you how we build actually the material, and then we will show you later how we build the crossovers, and we are coming later on back into the data management with What.io and the digital product passport. So yeah, thank you very much for today.